Welcome to Universal Tracker and the Quest for External Data, part of Sitecore Virtual Developer Day 2020. I'm Scott Gillis, lead consultant and Sitecore architect at Paragon Consulting in Cleveland, Ohio. I've been working with Sitecore since slightly after my eldest's birth, who recently turned 8. I've been honored with the Sitecore Technology MVP for the past 3 years, and hopefully at this time of you watching this recording, that would actually be 4. You can find me on my blog, thecodeaddict.wordpress.com. Find code samples, helpful scripts, as well as samples from today's demo at github.com/GillisSM. And you can always find me on Twitter and the Sitecore Slack channel via the handle, thecodeaddict. Our quest today doesn't begin in a smoky, dank tavern, but it begins with data. All the missing data that organizations are missing from their customers as they visit websites, interact through an app. Maybe they talk to your organization via a automated assistant. Or there's even the old-fashioned call center scenario. Pick up a phone, talk to someone, get your questions answered, as well as a physical location that may have a self-help kiosk. These are important steps in a customer's journey to your organization. And these are all things that are missing when it comes to Sitecore analytics in most instances. You've installed Sitecore, you have heavy marketing automation set up, but you're still missing these important points in time that the customer is interacting with your organization through those mobile apps, through the physical location. And what Universal Tracker does is it gives us a solution to bring these ancillary, outside of Sitecore data points into Sitecore so we can take advantage of richer data, feed it into machine learning and Sitecore Cortex so we can build better customer journeys. That's what these important non-Sitecore based interactions mean. Better data, better customer journeys, meaning happier customers. So the Universal Tracker can be summed up as a highly scalable and efficient web endpoint for the collection of events occurring during an interaction on any channel. So what this means is we start at the channel level. These are those different avenues customers are coming to us that isn't through our Sitecore implementation. It could be a custom mobile app. It could be digital home assistants. Alexa, tell me what the weather's like. Alexa, is there a rock climbing event occurring somewhere? It could be another website property that the organization owns, as well as some sort of call center scenario. I've moved to a new area. I need a new primary care physician. I pick up the phone and start making calls. No matter what avenue or channel a customer comes to us, it happens at a certain point in time. And that's what an interaction is. It's a date and a time. It's a specific point. And during the interaction, multiple events occur. These are goals the customer has in mind. These are also the goals we as an organization are trying to lead our customer to. It could be registering for that local rock climbing event. It could be scheduling a family event, hot air balloon over the Rocky Mountains. Whatever it may be, it's bringing the customer closer to the organization, providing value to them. So Universal Tracker is scalable and it's efficient. What you see on the screen now is a common Sitecore Experience Platform Azure topology diagram. Across the middle, you see our app services with different CDs, CMs, even our collection, and lots of databases from X profile to content, as well as our reporting databases that are needed. But nowhere on this diagram are you going to find the Universal Tracker. That's because the Universal Tracker, being efficient and highly scalable, sits outside of our core Sitecore implementation. It sits off to the side. And it really only knows about Sitecore at one point, and that's the XCollect service. By having minimal knowledge of Sitecore, it's able to scale quickly, and it's also much more efficient. And we'll get into that a little bit more as we move through the presentation. So what allows the Universal Tracker to be efficient and scalable? Well, it's because it's been built on top of the Sitecore host application. The Sitecore host application framework, for those that might not know, is built on the Microsoft.NET core libraries, allowing it to be cross-platform ready. This means we can deploy our code, our application to an IoT device, a mobile device, even a container of some sort out in the cloud. This Sitecore host framework provides us a standardized way of doing dependency injection or service registration, allows us a common methodology for configuration management, as well as gives us some nice parameters around command line usage for installation, service starting, service stopping. And finally, one of its crowning jewels is this idea of a dynamic plug-in loading mechanism. A plugin, or a module, as I like to call it, is a small bit of concentrated logic. It does one or two things really, really well. By assembling one or more of these plugins together through configuration, we create an application that's deployed on Sitecore host. And these features of Sitecore host application allows Universal Tracker to be small and highly scalable and very efficient. Because again, it's focused on one thing: collecting data, process that data, and sending it off to Sitecore. What does that look like? Well, it starts with our channel, interaction, and event. From there, it gets fed into Universal Tracker, built on type of Sitecore host, and eventually makes it into Sitecore via the XConnect service endpoint. If we take the lid off of things a little bit and look at Universal Tracker, it actually breaks down to three components. The first being our collection service. The collection service is the public and REST endpoint, contains three publicly available REST API endpoints that we can push our event, interaction, and channel data to. Once collection service has it, it does minimal processing and sends it into SQL. At that point, the processing engine steps in. The processing engine pulls this interaction data that we've collected out of SQL, does additional modifications to the data, and finally pushes it into XConnect service. The processing engine is unique in the fact that it's built on top of the Sitecore pipeline architecture. I mean, there's unique points in time where we as the development team could expand what Universal Tracker does during processing to enhance or better the data. The first step in this pipeline, the first pipeline we can interact with, is the pre-filter or scrubbing pipeline. We can add rules at the pre-filter state that tells Universal Tracker what data to actually use and what data to throw out. So for example, Sandy starts on a custom mobile app for Rainfly Adventures. Rainfly Adventures is a fictitious company that does outdoor adventure vacation packages for family as well as local outdoor events, hoping to bring people back out to become one with nature. So she's on her mobile device at a certain time, say during her morning coffee break. She's looking for upcoming local rock climbing events that are occurring. She sees one she's interested in, clicks the download more button 3 or 4 times. Well, collection service has gathered those 3 or 4 clicks and stores them off into the SQL. Well, during pre-filter, we can realize that Sally has had 3 clicks of the same event. Well, no one actually clicks 3 times to request more information. So we can assume 2 of those are probably bad or extra clicks. In that regard, we can throw those 2 out and keep our data cleaner. In addition, scrubbing can allow us to enhance, update the data. Say a name or some value comes in as HTML encoded. In that regard, during scrubbing, we can decode it appropriately for usage. Next is the enrichment state. And this is where there's some real advantage to Universal Tracker. During enrichment, we can pull data from external sources, potentially Xprofile, maybe our Salesforce CRM. But wherever it is, we can pull data to enhance the information we know. For an example, in Sally's case, she was on her mobile device. We have a Latin long of where she was looking things up at. Well, when we get into Sitecore Cortex and our machine learning algorithm, we really want city, state, zip. Well, enrichment stage is when we can take that Latin long, do the conversion to the appropriate city, state, and zip code. And the final stage is a post-filter and a packaging stage. Post-filter, similar to pre-filter, rules can be applied to throw data out that we no longer want after enrichment, or that just doesn't fit the need at the time. In addition, it takes packaging and takes all the information as collected during collection service and places them in the appropriate XConnect modeling for push to XConnect service. We're scalable. So we've talked about how we're efficient and we can scale because of the Sitecore host framework. What does that scaling look like that allows us to be efficient and handle large volumes of data from our different channels? A default install is going to provide you all your channels coming to a single collection service, to a single database, and to a single processing engine. Very quickly, though, you may realize that you have a lot of data coming from some channels versus others, which would be expected. This is information we haven't had in the past. It's information we've been missing from our analytics reporting, so we may have to scale out. One of the most common scale paths you would take would be to assign certain channels to a single collection service, to a single database, to a single processing engine. And this is probably one of the more common scenarios of scale you'll hit. And really this becomes needed because SQL is going to be our performance bottleneck. SQL is strong, it's powerful, it does a lot. When you're pushing high volumes of small data, as collection service is going to do because of these events that are occurring and they're occurring constantly, SQL can become bogged down. So you can naturally take this to its conclusion of a single channel, to a single collection service, to a single database, to a single processing service. At any point in time, you could put multiple collection services to a single channel. So now that we've talked about Universal Tracker, being able to collect this omni-channel type data from things outside of our Sitecore implementation, you may be thinking of two tools that you may be a little familiar with already. Maybe your partners talk to you about them. The first being Federated Experience Manager, or FXM, and the second is XConnect Service API. And true, Universal Tracker does sound like a little bit of each of these. Universal Tracker really is the evolution of the idea of omni-channel data gathering for Sitecore. It takes pieces and parts from each of these and combines them into a single, highly scalable, highly efficient web endpoint product for us to collect this data that's so critical to the customer journey, but many organizations are missing out on right now. So in terms of differences, similarities to FXM, for starters, Federated Experience Manager gets configured, managed from within Sitecore, from within our Sitecore administrative screens. Whereas Universal Tracker, as we'll see in a few slides, is a much more file-based configuration that requires a little bit of technical help. FXM, though, is focused truly on just web properties. That's where its power is. You place a JSON beacon, a JavaScript beacon produced from that configuration on your web property, and you end up collecting the analytics as you go, which is helpful, again, in a very narrow window, a single channel. Universal Tracker, on the other hand, because of its public REST API endpoints, allows us to collect data from any channel we deem necessary. FXM, in my experience, has difficulties when it comes to an authorization scenario, where maybe you have a wall that a user needs to log in before they can see content, perform actions such as registration. And because of this, FXM starts to get a little funny and doesn't necessarily always collect the data as you would expect. Again, Universal Tracker being just a public endpoint data is pushed to, there's no real callback that occurs with that JavaScript beacon required for FXM. Now, FXM, though, is a little bit more powerful in terms of it allows you to push personalized content or just straight content to that web property. So that's helpful in one regard. But nowadays, we now have Sitecore JSS as well as JSON device layouts inside of SXA that provides us an almost better headless scenario for pulling personalized content or just normal content from Sitecore to be used somewhere else. The XConnect Service API, well, its biggest drawback when we start talking about other devices, other instances that we want to start collecting data from is its need for a trusted communication. There's many developers, I'm sure, listening to this session that have faced the infamous XConnect service cannot start, cannot communicate to XConnect service during installation. And that's because the certificate, as required by XConnect service, hasn't been properly trusted, hasn't been properly installed, or the thumbprint's wrong in one of the configs. And it can be a little bit of a mystery and take a lot of hours to get to the bottom of which of the three or all three of those common issues have occurred. In addition, we don't want to deploy that security certificate to someone's iPhone or Android device. That just isn't good security practice for our organization. XConnect service also is meant to deal with completed data, so all the events, the interactions fully done, and I don't expect to gather any more events during this interaction on this channel. This is probably another area you've commonly experienced, maybe giving a demo of Sitecore, seeing a demo of Sitecore, where someone's clicked through, closed down their browser, and said, okay, when I open it up, now the banner is going to show us sunshine. Turns out nothing happens. And that's because there's the 20-minute delay for a session to expire before the completed data set gets processed into XConnect service. And this isn't helpful when we're talking about non-Sitecore implemented avenues, such as a mobile device, where people are very quick, moving from one action to another, and trying to push these events very quickly as they occur, these almost micro events, if you would. And finally, and similarly to the whole completed data set scenario, is XConnect is not meant to process lots of small chunks of data that we're going to be creating through Universal Tracker. Most of the data for XConnect is a fully completed session, a fully completed interaction of multiple events in a larger batch scenario. So now that we've kind of walked through how Universal Tracker is highly scalable, it's efficient because it's built on top of the Sitecore host framework, and it provides us the opportunity to pull data from all these non-Sitecore based channels that our customers are interacting with us. We'll look at a little bit more of the nuts and bolts to Universal Tracker. Sitecore host framework is built around the idea of plugins, and Universal Tracker is no different. Universal Tracker has two applications to it, the collection service and the processing engine, which we've already mentioned in the earlier slides. Now we're going to look at specifically collection service and the plugins that are combined to give us the collection service application. The first is Sitecore tracking. Sitecore tracking contains those public REST APIs. Also includes some modeling information of how to interpret the data received on the API and what needs to happen to it when it gets pushed to SQL. Next is Sitecore.tracking.status. This is a hyper-focused plugin. All it does is gives us a /status route, and via configuration reports on one or more elements of the collection service. In this case, it's, can I write to my log, and can I talk to SQL? Next is the Tracking.SQL plugin. Again, another hyper-focused plugin that basically reads and writes data from SQL. Not too concerned with the model that's going in or out. That's handled by that Sitecore tracking plugin. Next is the processing engine. It repeats those first three plugins. Again, that reuse scenario of how we can wire plugins in multiple ways for different applications. In this case, processing engine adds a check for XConnect to its status tracking via configuration. In addition to those three, processing engine includes the processing.channel management plugin. This plugin serves to define the channels we're expecting to process. It is also the point where we would configure and deploy any code for that pre-filter scrub, enrichment, and post-filter packaging stages of the processing pipeline. And finally, there's the processing engine. As its name would suggest, this is what the service is included in that gets installed to the system, as well as manages the threads and the reading and the writing of the data that's required for processing. Before we get into the actual installation, I wanted to call out for those, which I'm sure is many, that aren't familiar with the Sitecore host application framework configuration load pattern. It'll feel a little similar to what we would expect in a standard Sitecore experience platform deployment, but I felt it was important to give us a little bit of background before we go ahead and install. On the left here, you'll see a sudo folder directory that's going to kind of serve as our map as we move through where the different files for configuration get loaded. Sitecore host application is our root. This will normally be installed at C drive and ipub root. Configuration overrides uses the standard Sitecore patching methodology. So if you can use your patch :delete, patch attribute, patch before, patch after type of attribution of your override configs. So everything begins at the plugin level. So Sitecore, that directory is going to exist, then the name of the plugin. And inside there'll be a config directory. And any files, .xml, .json inside a config will be loaded first in alphabetical order. It'll then look at a /environment directory. This is one you'll normally add yourself. Potentially, and basically, as it would suggest, you can define specific environments that this deployment is using, and then really kind of carry each environment's configuration files across. After we load from plugin, we're going to go up to the root application to /config and load those alphabetically again. And again, I'll check for environment /config, and those will be the configuration loaded. So at this point in time, host environment configuration files are going to be winning and setting the value. I will call out that this config folder isn't there by default, and this is where you, as the installer, implementer of the Sitecore host application, would manually create this during install And this is where your plugin level overrides really should be placed. From there, we're going to go up to the Sitecore runtime directory, and again, looking at the environment level. Sitecore runtime is really meant to be high overarching application level configuration files, so not necessarily specifics to each individual plugin should be overridden at this level. At this point, we have the opportunity to move away from files and actually load from a system environment variable prefixed Sitecore _. So this is a unique piece to the Sitecore host application framework, but it's also kind of helpful if you have multiple host applications running on a server. Maybe they all need to communicate to a single database. Well, instead of updating each individual host application, we can do it at a system level. And then finally, Sitecore host application provides us that common command line interface parameter architecture, so we can actually finally override at the command line level during starting or running of a process or an application. This, I think, is a unique prospect if you have a unique value you want to just test out, and you don't want to have to monkey about with which config file do I need to update. I could just run it, run my test, and then determine if that really should become the proper value. Installation is kind of our next step here, looking at nuts and bolts. Now that we have a little bit of background around that plugin, configuration loading based on the plugins and the whole Sitecore host application. As you can see here, installing isn't that difficult when compared to a full Sitecore experience platform deployment. And it really all starts with a similarly syntax PowerShell command that we run 3 times. The first time we run it is to install our SQL databases. And our parameters are going to be more or less the same if you're doing an Azure deploy, or in this case, an on-prem or to like a virtual machine scenario. We tell it where the DAC is, the DAC pack, so what the SQL package looks like and where that locates. And this path has to be a fully qualified path. So C drive something, E drive something, or the script does fail out. Give it where our SQL server is, the name of our SQL server or the IP address, what we're going to name this database. And this is important to take note of as it'll be reused in the other 2 scripts. And finally, a username and password of a SQL account that has permissions to create new databases. Next is the collection service installation. Again, it's an on-prem deploy. We tell it where our Sitecore license is located, so it can be copied over appropriately. Again, a fully qualified path. Where the web deploy package is, so where the folder structure, the code is that will be deployed, again, a fully qualified path. We can provide the database connection string. This will override the config during installation of the tracking.sql plugin, so it knows where the database is as named during the first script. Then there's some optional values. The 2 I have shown on the screen is the instance name and IIS app pool name. So what should this be installed as inside of IIS? There's a default one. It's like sitecore.universaltracker.collection service, which I don't find to be very helpful. And then finally, there is a override attribute to tell it a different install path. And then the final one is going to be for our processing engine. So you'll see repeated license, deploy path, connection string. I'll call out the bottom 3 optional parameters specific to processing engine. And this is the service name, display name description of that processing service that will be installed. Again, there's a default value, but it isn't necessarily as useful or helpful if someone else comes in and takes a look at the server. With everything installed, it's important to go through, and especially for collection service, update the install and make sure SSL is appropriately set up. Processing engine isn't necessarily as important as it doesn't really have a public interface anyone's going to call in to. Most of it's handled by that registered Windows service. After this, we got to let Universal Tracker finally know about our Sitecore implementation, that single point of contact, which is the XConnect endpoint. I've got it shown here how we would do that scripted. We'd create an environment config directory at our root, and then simply copy the configuration file from processing engine to that location. We would then need to do a simple update of 2 of the values, first being the service URL, the second being client certificate. What that looks like in XML, a little bit easier to read, just not as fancy. would be these two values, service URL and client certificate. With that in place, we can simply then do a status check on collection service and the processing engine. So this uses that tracking.status plugin that really serves one purpose. Can I talk to the log? Can I talk to SQL on the collection service side? On the processing engine side, can I log? Can I talk to SQL? And then most importantly, can I communicate to XConnect? If something doesn't work, it'll show red. It may say failed. It may say errored. If you're lucky, you'll get a little bit of messaging, but in most cases, you'll end up looking at the log to see what happened. And with that, we've actually installed Universal Tracker. Now, there's a little bit of a post step that needs to occur, but at this point, we could actually start pushing data to the Universal Tracker. It just won't start processing just yet. And that's because we need to update the channel types JSON configuration file of the processing channel management so it knows about the different channels available in our Sitecore implementation that have been deployed to XConnect and to analytics for the proper data processing and collection. So this is what the JSON file would look like. And we will start first at where do we get channel information? Well, you come into your marketing control panel, taxonomies, channel, offline, online, depending on what type of channel. You would then drill down through some grouping and finally arrive at some sort of channel. In our case, the Rainfly Adventures web. And then we just simply grab the item ID. So at this point in time, there's a level of communication that happens outside of Universal Tracker between those installing and setting up and the marketing and content teams that may control these actual channels that content goes out at. Some could argue that we need a back and forth, so this Universal Tracker is pre-aware of these, but that really starts to cut into some of the scalability and efficiency as the more points of contact we have with Sitecore Experience Platform, the little bit trickier it becomes to scale and to quickly scale and make Universal Tracker efficient, because now we have to worry about additional connections. So once this ID is known, it gets moved into the channel types JSON as the ID value. We then can provide a name. It doesn't have to be the same name as what's found in the marketing control panel, but it's very helpful as this allows both sides of the fence, the marketing side and the technical side managing the installation, to know what they're talking about. We then have isActive flag. It's a true or false. This basically tells processing engine, is this a channel I should be worried about and start processing data from? So it's possible we could have multiple processing engines reading from a single database that collection services have pushed data to, but each of them uniquely process different channels. And this is very helpful if we have specific enrichment or pre-filter scrub steps that need to be taken for only certain channels. This allows that code only to be ran when needed. Timeout value, this is listed in seconds. And this is really how much time should the processing engine wait before it decides to start processing events for an interaction. So the default value is 1200 seconds or 20 minutes, but we could set this as high or as low as needed per the needs of the channel, how quickly we expect the data to move through. So the data itself, we've installed, we know we can scale, we know there's a lot of points of contact with our customers we need to start pulling data from. This all happens through three REST web endpoints called put interaction, post complete, and put event. We can call these through custom.NET code, custom any code that wraps a web client to do the pushes of data. You can use JavaScript directly in the web property. There's also available a SDK, open source, called Sitecore.universaltracker.mobile SDK that provides us some nice SDK objects, management of the whole request and response of the data that gets sent to collection service. We're going to take a look at these three via a JSON, so as if we were sending things just purely through JavaScript on a web property. I feel like it's a little bit cleaner, a little easier for us to walk through than looking at an SDK object model. So the first thing that always happens, no matter if it's SDK or you're manually writing things out, is to put an interaction to collection service. This is the start point. It begins with a channel ID that maps to one of those values and channel types, which should map to something inside the media control panel. From there, we have an initiator, contact or brand. Contact would mean, in most cases, okay, the customer is initiating this interaction. They came to the website. They opened the app. It could be a brand initiated. Maybe we sent a special email campaign that had a special link. Maybe it's the brand making the call via some sort of call center follow-up scenario. Next is contact source, contact identifier. Those that have done a lot of XDB and XConnect work may recognize these values. These do map to similarly named properties in the XDB and X profile. A contact or a profile record can have multiple sources and a corresponding identifier, which basically says, okay, from this source, from this channel, this is who the person is. If we know, maybe through that email campaign or through the registration mobile app, who this person is, we can then supply that information here. And this allows all the data collected through collection services to end up on the same record. Either way, we still have the ability to use contact merge as more and more data is collected to combine different records. Finally, there's an optional events array. So during the start of an interaction, if there's a known event or multiple events, those could be registered right away with collection service. If this is successful, you're going to get a 201 created response. And in the body will be a GUID called the tracking interaction ID. And that's important for the next step, which is a put to event. All put event does is gives us an endpoint to push events, one or more at a time, as they occur on these non-Sitecore channels. An event object has a type, and type is actually defined in the tracking config file, and basically is a name given to a specific .NET XConnect model. So if we've extended XConnect with our own custom models, we can deploy that to our universal tracker and appropriately list it and then track. Next is definition ID. Definition ID works for goals, events, outcomes, and is really taken from Sitecore. Here we have the brochure request goal inside of marketing control panel, and basically this ID is what gets placed in definition ID. Similarly, the argument could be made, okay, I should have a REST call that says, give me all the goals available. Be helpful. Again, they cut out a little bit of communication that needs to occur, but it also, again, creates that additional communication point to Sitecore, which we're trying to limit that interface between the two systems for scalability and efficiency. Page view, you'll see doesn't have definition ID, but instead has a URL. And this is because some types don't need a definition ID, but other custom data values. In this case, a page view is what's the URL it's landing on. Timestamps are important. We need to know when did this event happen in terms of the interaction. Was it at the start? Was it at the end? Was it in the middle? This is important so we can better map the customer journey during this interaction. And finally, and most importantly, the tracking interaction ID that came from the initial put to interaction. Once all of our events are done and we know that the interaction is completed, we can do a post to the complete method, and all we do is pass it the tracking interaction ID value. Now, as we mentioned with the track channel types JSON, there's a timeout value, which means the processing engine or universal tracker, really in that regard, is smart enough to realize when an interaction is completed and start processing. So in most cases, we may not know when to push this post-complete messaging, and it's fine. Our data is still going to process appropriately and end up inside of XConnect, which eventually aggregates down to X profile, XDB, and hopefully into Sitecore Cortex for better customer journey mapping. So with that information in mind, we're going to switch over and do a little bit of a demo and just kind of see some raw data as it moves around. So again, we're going to deal with things kind of from a JSON perspective. Instead of just clicking through a web and showing things, I'll narrate you a story, and we'll kind of see how our data ends up. So on the right here is going to be our messages into collection service. And on the left is our data, the database for Universal Tracker. So we'll get that warmed up. So our story really starts with John, who is a user of Habitat Home Services. He recently saw a tweet message that they purchased Free and Flight Adventures, which we said is a a company that does outdoor adventure vacation packages, local events. So clicking through, he's interested. He and his buddies have been talking about a big adventure this summer for him, just to kind of do something a little different out of the ordinary. So he hits the website, coming through the click. We know his name is John, based on some other information we've gathered. We're going to send a goal such as called first contact. So we'll send this request. And it'll take a second as collection service warms up here. And we'll see that we get a 201 created message returned and the all-important tracking interaction ID value. If we take a look over here at our actual data sets, at the top we get our actual interaction. So this ID matches the channel we came in on, when it was created, and very most interestingly, the data that was collected for this call. And we'll see that the JSON actually gets stored. So collection service is quick. It's not worried about parsing the JSON that we actually sent over by much. It's just storing it. It's not worried about processing. That's why we have a processing engine. And you'll see the data itself doesn't look too different from what we sent. We have our source information, our user agent. You may see a few additional values such as IP info and web visit. These are just XConnect models that we could enhance. So if we knew some web request information or IP info had been captured, we could send those in appropriate models. Then the second table is the initial event. So we'll take a look at that. And again, you'll see not much has happened. This is a little clearer. You can see that we did get a little type setting. So tracking does do a little bit of modeling and telling us what XConnect model we should be handling when it comes time to do our processing. So now that we've started our contact, we made first contact, we're going to go through and do some events. So John does a search for rugged trips. Through the search results, he found the backcountry packages page. And during his review of that, he got excited, requested a brochure, and also downloaded some information to share with his friends. So we'll send this request. As you'll see, we actually got a 500 error message. And our messaging is fairly straightforward. Could not parse event because this ID is no longer valid. And what this actually means is because I talked just long enough, Universal Tracker didn't receive any more events, so it started processing our data. So if we were to come over to XProfile, leveraging the very handy filtering mechanism, and drill down in our channels to the Rainfly Adventures web, and do an apply, we'll see that we have one record that occurred 1 hour and 2 minutes ago, which would be appropriate. We're doing a 1 hour delay. If we open up this record, we can see our goal, first contact, occurred today. So we can see how quickly that data processed for us to start making decisions and potentially even personalized content. So we'll switch over here. Our logic is smart enough to realize when this happens and generates a new start of an interaction. But this time we're going to push all the events in one go. So if we send that request, we get a tracking ID, it's been created, and we'll come down and call to complete this time. We get a true, it accepted our interaction ID. If we execute our query, we see we have our interaction, 7 dB, and then the number of events. So all 5 events that we sent over. So if we switch back over to our experience profile, refresh it. Whoa, crazy tree build. And again, filter down so we can only looking at today's data. Drill down to our channel, to Rainfly Adventures, and apply. All right, we got another minute. It's still in processing, which is fine. So there is one other element I did want to call out is this engagement value. So what we can actually do during an event send is actually specify a engaged score value. And this will override the value as the goal or outcome is listed inside Marketing Control Panel, which provides us some flexibility when we have very specific channels of data that are coming in that may be a higher value download through a mobile app versus download just on the general web, for example. And let's see if that's quick enough. Yep, now our data is processed. So we can come through and refresh. Oh, we need, well, we forgot. Yeah. Posted Scott. So we actually posted our data to the wrong user this time, but the same experience should be shown on the slightly different channel. Greenfly Adventures, there we go. There you go, 32 minutes ago. And we see our download, our search, and our opportunity that was created. And what's kind of nice is you could drill through, select the event, and kind of start seeing, okay, he visited which page. So very nice. And it feels just like if they were interacting with your Sitecore implementation in that regard. So with that, that concludes our presentation and introduction to the Universal Tracker. Hopefully you realize how you can start collecting all these ancillary non-Sitecore implemented data points, connections that you and your customers are having that have yet to be collected to build better customer journeys. Feel free to reach out to me at thecodeaddict@wordpress.com. You can also always find me on Twitter and the Sitecore Slack community with the handle thecodeaddict.